Assalamualaikum and selamat sejahtera, especially to my lecturer, IR MAZLAN AHMAD. My name is Muhammad Zainam Ismail and my matric number is B092010-266 and I am from class 2 BMMH11. So today me and my group will give a presentation about torsional loadings, evaluation from actual structure. So what is free body diagram? A free body diagram is a graphical illustration used to visualize the applied force, moments and resulting reactions on a body in a given condition. So, we have captured a real-life application and we want to show the calculation of forces and moment using the free body diagram. After that, we have to find torsional loading evaluation. So, what is torsional loading? Torsional loading is a test that twists a material or test component to a specific degree with a specified force or until the material fails in torsion. The twisting force of a torsion test is applied. The rotating moment may also be applied to both ends of the sample, but the ends must be rotated in opposite directions. Torsion force is a twisting force that is applied on an object by twisting one end when the other is held in position or twisted in the position of opposite direction. Different materials have a different way of responding to torsion. Some will deform, crack or even break depending on the type of material.
Okay, let's go to my part, objective. Firstly, to study the tensional loading torsion bar at vehicle, and then to develop EOE for the force act on the structure, to determine the FBD at actual structure, to determine factor of safety used in torsion bar, to find the maximum force that will fail the torsion, to determine the behavior of a material or test sample exhibit when twisted or under torsional force. Okay, let's go to other slide. Next slide. Okay, this picture shows us working of torsion bar. You can see the shaft rotation force transmission. Okay, that's all from me. I pass to other members. Thank you.
Assalamualaikum, my name is Ishaq bin Muhammad. I will continue to the calculation of the structure. First of all, the moment of y is equal to 0. The torque is equal to load times length of the rod. From here, the torque is equal to 800 Newton times the length of material is 0.09 meter. We get here is 72 Newton meter. After that, we have to find the area by using the area equation. 2 pi multiplied by diameter power of 2 divided by 4. We get here 2.8274 power of -5 meter square. From the torsional constant or polar of inertia is equal to pi times diameter power of 4 divided by 32. We get 1.2723 times 10 power of -10 meter power of 4. After that, the yielding strength of the shaft is force divided by sectional area. 800 Newton divided area is 2.8274 meter square. We get here 282.95 megapascal. To get the maximum length to break the shaft is by using force times length divided by area times Young modulus of material. We get 800 Newton times 0.09 meter divided by area 2.8274 power of -5 times 800 giga of Young modulus. There will be 3.183 10 power of -5 meter for the maximum length of the shaft. Angle of twist after apply the force is torque time length divided by modulus rigidity multiplied by torsional constant. We get the calculation is 0.619 radian or 30 degrees tweak. 35-degree twist. From the previous calculation, we can assume that working allowable force on the shaft by using the tau times y equal to torque time radius divided by torsional constant, and we get 0.0 Newton for the torque. Last but not least, the safety factor is by divide the field yielding with the allowable force, we get 2 for the factor of the safety. That's all from me. I will pass to my friend to continue the slide.
Hello, our group discussion discuss the mechanism of a torque as a moment of twist a structure. Since twist apply a shear strength, we expect that torque will apply a shear stress. The relationship between a torque and a shear stress show as follow: torque equal to any distance times torque apply over the polar moment of inertia. After completing a list down the formula we need, we use a Hooke's law inertia to see how they are related. Hooke's law enable us to calculate the angle of a twist, where the formula are torque apply times beam length per shear modulus times torsional constant. Here we also calculate the SF, which is safety factor. It is when the ratio of the ultimate strength of a member or piece of material to the actual stress. We also calculate the SF, which is a safety factor, when the ratio of the ultimate strength of a member or piece of material to actual stress or maximum permissible stress when in use. The formula are as follow: Fs equal to torque mass over torque allowed. With the equation above, FOS of a 2 means that a component will fail at twice the design load, and so on. Different industries have different ideas on what required margin of safety should be. One of the difficulties associated with using FOS or SF is some ambiguity. For our group conclusion, following the tool that we examined, we can conclude that calculations and the approach of the assignment are based on the learning outcome of teaching, where we able to apply to our knowledge of how to calculate the torque, the torsion and the stress, and the maximum yield stress as follow. By using the Hooke's law, we can relate this strain to the stress within. To conclude the finding of our assignment, we can conclude the finding of our assignment is regarding to the Hooke's law principle. As shown, the maximum force of the shaft tend to break are able to calculate, and also the way of working or being called the free body diagram shows how the tool apply to the moment and the force toward to the tool are being examined. That's all from our groups. Thank you.